Alright, so now let's start using Substance Painter. The first thing which we want to do is create a new project. So let's come over here to File, click on New. That gives us a new project window. Under Template, we are fine with the default template. File, this is where we pick our low poly mesh. So click on Select, pick a low poly mesh and open it. Under Import Settings, we have settings like Create a Texture Set per UDIM Tile and Import Cameras. Import cameras is something new they have added. So if you have cameras you want to export from some 3D application, this is where you enable it. Create a texture set per UDIM tile. If you have UDIMs, Substance will divide each of them in different texture set. UDIM is a form of UV layout film uses, but for our cases, all of our UV sets are divided according to material ID, so we don't have to enable it. Under project settings, we have document resolution. This is going to define the resolution every texture set will have by default. Below that, we have normal map format. It's going to be important if you are baking for Unreal Engine to have DirectX. If you know, some software has Z-axis as up and some software have Z-axis as sideways. For Unreal Engine, we are going to use DirectX. We can always change the kind of normal map which we have in future, but it's always a good idea to have things done correctly from the beginning. Under Compute Tangent Space per Fragment. Compute Tangent Space per Fragment is one more thing that is Unreal specific. So if we are baking for Unreal Engine, let's keep it on. If you are baking it for Unity, it's recommended to turn it off. Down below, we can load in some mesh maps which you have baked outside Substance if you want to bring it in. I usually end up importing it afterwards. It's always easy to just drag and drop it here. So let's hit OK. Alright, so we have our 3D model loaded in. There are some shading issues because this model was done a long time ago and I did not know better. But we are going to go about tricks, how to fix that or how to avoid it in future for the second week. Now what we have right here is a straight up 3D model without any supporting maps from the last time. If I try using any materials like, let's come in down here. Let's pick in machinery and drag and drop in my layers. So without any mesh maps, the Substance material are not gonna work properly. I can always go in and hand paint some of the things, but that's not what Substance is known for. To use Substance completely to its fullest potential, we are going to bake some mesh maps. So let's delete these guys. Let's go over to texture set settings, and if I scroll down, we can find a bake mesh maps button. Let's click on it. That gives us the baking window. So baking, if someone has not done it before, simply put, we are taking our high detailed dense mesh or our high res sculpt and low poly game res mesh, keeping them in same space and in 3D space and running a process called baking, which transfers the high res detail into a texture and fakes our low poly to look more detailed than it actually is. Under common parameters, let's define our resolution for the baked maps. Let's keep it at 4K. Dilation width is basically how much dilation will happen outside your UV border. So Substance will blur out some pixels outside your UV border. Dilation is something which we use to prevent MIP mapping, not MIP mapping, to prevent some obvious UV seams when MIP mapping happens. MIP mapping basically is when your object goes further away from the camera, your texture gets down-resed, and when it does, there are some obvious UV seams. To prevent it, we just have some dilation on our UV borders. So let's keep it at 4 for now. Let's not hit enter. This is what Substance does when you do. Apply diffusion is fine. High poly parameters, use low poly mesh as high poly mesh. Since we are using a high poly mesh, we don't need to turn it on. Under high definition mesh, we are going to click on this guy. And this is where we pick our high mesh. You can add more high poly if you have those. You can delete your high poly just by clicking here and here. Let's add this guy again. You might notice these icons changed after I added my high poly. That basically means our normal map, ID map, AO map, and thickness map needs a high poly to work properly. We don't have a cage, we are not going to use one because Substance by default does a pretty good job at calculating its own cage. If not, if we are facing some issues, we can just play with these values and get something right. Down below, these settings should work fine. Under mesh, we are going to pick in by mesh names. This is something that replaced the exploding process. To keep things simple, we are going to keep that topic for the next week. Under anti-aliasing, the higher the subsampling is, the better your map will be. Do keep in mind, the higher you go, the more time it will take for the baking, especially for your ambient occlusion and thickness. I haven't found any difference between 2x2 and 8x8. So to save us some time, let's just keep it at 2x2 for AO and thickness. For now, let's make it 8x8. High poly mesh suffix and low poly mesh suffix should be fine. Let's come over to the left. So these are the mesh maps Substance will use and bake down. I like to disable everything but keep my normal map on. So let's say if you have any issues while baking or some bleeding, you can find it out with just baking one map and you don't have to spend time wasting all of these maps. You can also reduce your output size to 1K while you're testing your bake to save some time, but I haven't found any drastic change between 1K and 4K, so let's just keep it at 4. Let's go over to bake low robot mesh maps. If I pick this guy, this is going to bake all of these maps with these default setting. But right now we're just going to focus on the robot. So let's click on this. So I went in and skipped the baking time. It took about few minutes to bake my normal map down. One thing that Substance does pretty good is it takes your high poly mesh and save a cached file. So next time when you bake the same thing, it's going to take less time. Baking time in Substance is pretty good compared to other packages. Sometimes I have baked 50 million polygons with 8x8 sampling in 8K and it took about like an hour. So the sense of time which baking will take will comes with experience. Right now we don't have any dense mesh, so it's just going to take a few minutes. So after our normal map bake is done, let's go in and inspect our mesh to see there's no visible issues, which there is none right now. And if I press in B, I can scroll through other map and go to my normal map. See how it's compensating for the shading issue which we had and making it look much more smoother. After baking down our normal map, let's come over to bake mesh maps again and let's bake down other things. So let's disable normal map. Let's select world space normal, ID, curvature and position. You're gonna keep ambient occlusion and thickness for last as they take the longest time. One thing before we do this, let's click on ID. It opens the setting for the ID map. So right now we don't have any specific set to generate ID map for this project. So let's just keep it at mesh ID underscore polygroup, and color generator, let's pick it as random. So it's gonna assign a random color to every single mesh we have, which is not combined with a vertex. And we can apply these settings to all of our texture sets just by clicking here. So after these settings, let's bake it down again. So we have our other map baked in. So let's go in and bake the final maps, which will be AO and thickness. AO and thickness have very similar settings, and most of these settings by default should be fine. Secondary rays will give you better AO map but longer the time. So let's go in and hit bake again. So I was baking in my AO with 8x8 subsampling and it kinda crashed my Substance. So that's one more thing to keep in mind. 8x8 for AO and thickness is pretty heavy. So let's go in and do that again. Let's enable AO and thickness and make sure our anti-aliasing is none or 2x2. Let's keep it at none so I can save some time. On our AO and thickness, the same thing will be fine. Let's bake it down. Okay, so we have our AO baked down, same for our thickness. So let's press B and scroll through our maps and see everything is baked down right. With our AO map, if I open my ambient occlusion, you see my AO map is occluding everything right now, even the base here. which is not wrong, but let's say the robot is supposed to move and his hips move somewhere else. This dark area will be baked down into all of our texture, which might look wrong in different poses. So to fix that, we're gonna go back to Bake Mesh Maps, go to our AO, and under Self Occlusion, let's pick in only same mesh names, disable thickness, and let's bake it down again. Okay, so now everything is being occluded on itself. So we don't have any of those darkening around the hips or around the fingers. So when this rotates or moves, it's not gonna look unnatural. Baking AO on itself or everything together can be case specific, but if you want to do that, the option is right here under AO and under Self Occlusion. So this is how we bake down all of our mesh maps inside Substance. And now using these, we can start using all of the smart materials, mask, generator, and everything Substance has to offer. So let's move on to the next thing. So we bake down our maps, and if this is your first time baking in Substance Painter or any other 3D package, you might not know what these maps are and what they do. So let's just go over those maps briefly here. Do keep in mind, knowing every technical things about those maps is not necessary. As long as you know how to bake them and how to get your work done out of them, it's all fine. But there's nothing wrong knowing more about it. So let's get started with that. So let's start with our normal map. In my opinion, this is one of the most important map for game art. It is used to help us fake the high-res information in our low-res information through a texture. Normal map, simply put, is just a 3-point bump map. Bump map, if you don't know, is a grayscale map that describes what bumps up and what bumps down. Thing with a bump map, a single bump map, is it can only define a bump in a single direction, either from top to bottom, front to back, or left to right. Normal maps solves that issue by having 3 bump maps plugged in RGB map, which define x-axis, y-axis, and z-axis, giving us 3-dimensional information. So normal map fakes the height and shadows to give us an illusion that we have those information from our high-res and our low-res. Normal map will not change your silhouette. So if you need any change in your silhouette, that should be done in your low poly. So let's have a look at our normal map inside Photoshop. So if I go over to my channels and switch between red, green, and blue, you can see our normal map is basically a 3 grayscale maps combined together to give us a result like this. From earlier, you might remember we baked our normal map as a DirectX. To change it to OpenGL, all I have to do is go to my green channel and invert it. So this switches between an OpenGL and a DirectX. So if I go over to my RGB, I can save it out as an OpenGL application. I often find myself using a wrong normal map in a wrong software or a different software which uses a different axis. It's really easy to change it. Just open your normal map in Photoshop, come to the green channel and invert it. Then save it out and you're good to go. Next up, we have our world space normal. So world space normal is kind of like a normal map, but it's baked down for a specific frame instead of a tangent space. World space normal, it's not that well used inside a game engine. Some game uses it because it's less expensive than a normal map, but Substance just uses it for its generator and other stuff. Then we have our ID map. ID map is just a color map where you assign a color to some specific element so you can have a mask created from it pretty fast. So let's say for an example, if you have a mechanical character who has 100 or thousands of bolt or screws on it. So let's say you created a metal material and you want to assign that to every screw he has. So you go in and you paint that mask one by one. That's going to be a really slow process. So if we have our ID baked down for all of those screws as, let's say, blue or red, we can create a mask out of that red selection. All we have to do is just pick that color and all of your 100 or thousands of screws are going to have that material. So it shortens the time it's going to take you to create a mask for some specific element if you have ID assigned to it already. Curvature is just going to describe your concavity and convexity, or just the curvature of it. We commonly use it to extract mass to define the places of extreme angles. So common examples will be day-to-day things we see around us. The aging or damage of many things like metal, wood, or plastics usually happens around the 90-degree angles or the edges of it. So we can extract a mask for that through our curvature. Other example would be dust or dirt sitting down in crevices of things and settling in. We can extract those maps out of curvature as well. Substance uses curvature map to do the exact same things. One thing with curvature map, you might want to bake a normal map before baking down a curvature map to get the best results. So next map is our position maps. So position maps assign a specific color to every single point in our 3D model, which basically helps Substance figure out where all of these element is, or basically every point is, like this point, this point, this point, this point, this point. Substance will figure it out through this map where they exist in the 3D space. Substance will use these to generate your dust, dirt, direction, or light generation. Then we have our thickness map. Thickness map basically describes how thick or how skinny the volume is. Personally, I haven't found any good way to use a thickness map inside Substance. Substance was using thickness map for some of its skin material, but it's kind of useless to a point. The only reason we bake down a thickness map is, let's say we are doing a face and we are going to use that thickness map as a starting point for our translucency map in Marmoset. Apart from that, I haven't come across any good reason to have a thickness map for everything apart from skin. So next we have our ambient occlusion. So you know how the corners of your room kind of looks dark around the places where it's 90-degree angle, kind of blackish around in there than they actually are. As soon as you point a flashlight to it, the darkness goes away. Basically, light getting trapped somewhere and making some part look darker than they actually are is our ambient occlusion. Substance uses AO to mask out dirt and other stuff. We use AO map in our engines too to help our stuff look more grounded and to have those ambient occlusion shadows built in. All of these maps are going to help Substance figure out how to generate things and does it magic.